In this video, we're going to define what a mole is, calculate moles using the mass and the relative molecular mass, use molar ratios to calculate the masses of reactants and products in a given equation, and use moles to calculate the concentration of a solution. The first thing we're going to do is look at what moles are. So we know that a million is represented by this number here, and that a dozen means we've got 12 of something. Well, a mole means we've got 6.02 times 10 to the power of 23 particles. So that could be 6.02 times 10 to the 23 atoms, for example, atoms of oxygen, or it could be 6.02 times 10 to the power of 23 particles, so it could be, for example, that number of water molecules. It's a very long number, so we write it out using standard form as 6.02 times 10 to the power of 23. You may sometimes also hear this called the Avogadro number, or the Avogadro constant, because it was named after the scientist Avogadro who discovered it. So effectively, a mole is just the amount of stuff we have. It's a way of working out how much of a chemical we've actually got. And we're going to look at how we can calculate this in a moment. So we've said that if we've got 1 mole of a substance, we've got 6.02 times 10 to the power of 23 lots of that particular thing, be it atoms or molecules. And 1 mole of a substance, of a chemical, is equal to its molecular mass. So, for example, magnesium has got the relative atomic mass of 24, which we looked at in the previous video. So 1 mole of magnesium would weigh 24 grams. Likewise, 1 mole of iron would weigh 56 grams, because an atom of iron has a molecular mass of 56. 1 mole of chlorine gas would have a mass of 2 times 35.5, because in Cl2 there are 2 chlorines. Each chlorine weighs 35.5, so 1 mole of chlorine would equal 71 grams. If we wanted to know how much 3 moles of oxygen weighed, we'd need to work out what the mass of 1 mole of oxygen would be. And oxygen gas is O2, so that would be 2 times 16, because each oxygen has a relative atomic mass of 16. And we then need 3 lots of that, because we want to see what the mass of 3 moles would be. So 3 moles of oxygen gas would have a mass of 96 grams. Likewise, if we wanted to know the mass of 1 mole of carbon dioxide, we'd need to work out the molecular mass of carbon dioxide, which would be 12 for the carbon, plus 2 lots of 16 for both oxygens, giving us a total mass of 44 grams. Now, we're going to look at an equation we can use to work this out for any given chemical with a given mass. So as you might have figured out from the examples we just looked at, to calculate the moles of something, we need to do the mass divided by the molecular mass. And this is a really key equation you need to learn and memorise going into the exam. You also need to be able to rearrange this for both the mass and the molecular mass. So if we change the subject of the equation to be the molecular mass, we would have the molecular mass, which would equal the mass divided by the number of moles. And we could also rearrange our equation to give us the mass being equal to the moles times by the molecular mass. So you'd better off just learning the main equation here, but being able to rearrange it to calculate the molecular mass and the mass. So let's look at a worked example and put this equation into practice. We need to calculate the number of moles in 16 grams of water. The first thing you should do is write out the equation and see if you need to rearrange it. So we know that moles equals mass divided by molecular mass. In this case, we'll be asked to calculate the number of moles, So we don't need to rearrange the equation, we can just use it as is. So we can say the moles of water will equal 16, which is the mass given in the question, divided by the molecular mass, which for water will be 2 times 1 for the hydrogens, plus 16 for the oxygen. If you're unsure on how to calculate the molecular mass, go back and watch the previous video where we cover that in more detail. This will give us a final answer of 0.89 moles. In this question, we've been asked to calculate the mass of 6 moles of carbon dioxide. So we'll start off by writing out the equation moles equals mass divided by relative molecular mass, but we'll now need to rearrange it to find out what the mass is. So we'll need to make the mass the subject of the equation. And once we've rearranged it, we can see the calculation we need to do is mass equals the moles times by the relative molecular mass. So the mass of CO2 is going to equal 6, which is the number of moles given in the question, multiplied by the relative molecular mass, which is going to be 12 from the carbon plus 2 times 16 from the oxygen. Again, watch the previous video if you're not sure on how to calculate this. This will give us a final answer of 264 grams. For this final worked example, we've been told that 0.5 moles of an element has a mass of 6 grams, and we need to identify the element. So we'll be able to identify the element by determining its relative molecular mass. We'll start off by writing the equation moles equals mass divided by relative molecular mass, and we'll now need to rearrange it to find out what the relative molecular mass is. And rearranged, that gives us the relative molecular mass being mass divided by moles. So in order to work this out, we're going to need to do the relative molecular mass being the mass divided by the moles, and both of these values are given in the question. So we do 6, which is the mass, divided by 0.5, which is the moles, which will give us an answer of 12, which means that the element must be carbon, because carbon has a relative atomic mass of 12. We're now going to look at something called molar ratios. So I've written out an equation here, which is the combustion of propane. So we've got C3H8 plus 5 lots of oxygen going to 3 lots of carbon dioxide and 4 lots of water. So what this essentially means is 1 mole of propane reacts with 5 moles of oxygen to produce 3 moles of carbon dioxide and 4 moles of water. And remember that each of these moles represents 6.02 times 10 to the power of 23 molecules. So 6.02 times 10 to the 23 molecules of propane plus 5 times 6.02 times 10 to the power of 23 molecules of oxygen, and so on. These are all ratios though. So if we instead started off with 10 moles of propane, we would need to react it with 50 moles of oxygen, producing 30 moles of carbon dioxide and 40 moles of water. Or if we started out with 2 moles of propane, we would need 10 moles of oxygen. Because as we can see, we've got 2 moles here, but there is 1 in the equation, so essentially we've times it by 2 to get down here. So we would need to have 10 moles of oxygen for this reaction. And that will give us 6 moles of carbon dioxide and 4 moles of water. Well, what about then if we had 2 moles of water? How would that work? Well, what we're essentially saying is that the water represents 4 lots of what's in the equation. So if we've got 2 moles, we can essentially say this 2 moles represents 4 lots of stuff. So to find out how many moles 1 lot is, we would do the amount of moles we've got divided by the value given in the equation. So do 2 divided by 4 to give us 0.5. So we can say that if we have got 2 moles of water, and that represents 4 moles in the equation, we can say that 1 mole would equal 0.5, and that would make sense, because if we times 0.5 by 4, we would get 2. So we can use one lot being 0.5 to work out how much of everything else we should have. So we would have 0.5 moles of propane, because remember we've already worked out that if we have got 2 moles of water, that means one lot in this equation represents 0.5. There is 1 mole of propane in the equation, therefore 0.5 times 1 equals 0.5. We've got 5 moles of oxygen in the equation. We know that 1 mole equals 0.5, therefore 0.5 times 5 gives us 2.5 moles of oxygen. And again, we apply the same logic to 3 moles of carbon dioxide. We've worked out that 1 mole equals 0.5, therefore 0.5 times 3 equals 1.5 moles of carbon dioxide. I'm going to look at this in practice in some equations and in some questions in a moment. In this question, we need to calculate the mass of ethanol that would burn in 100 grams of oxygen. The first thing we've done is just rewritten the equation so we can see it a little bit bigger. In the question, we're told that we're given 100 grams of oxygen, so the best place to start is by working out how many moles of oxygen we've got. We'll use the moles equals mass over relative molecular mass equation. So we'll use the 100 grams of oxygen divided by the 2 times 16 for the relative molecular mass, giving us 3.125 moles. So now we need to work out how many moles of ethanol that would give us. Remember, this 3.125 moles of oxygen represents the 3 lots of it in the equation. So we need to work out how much one lot would be worth. To do this, we need to divide the moles of oxygen by 3, because in the equation we're told that there are 3 equivalents of oxygen, so our moles of oxygen needs to be divided by 3 to tell us what one equivalent is. Dividing 3.125 by 3 gives us 1.04. We can then use this to work out how many moles of ethanol we've got. We know 1 mole in this equation is 1.04. There is only 1 mole of ethanol in the equation, so just times our moles by 1. So it'd stay being 1.04. The next step is to work out a mass of ethanol from that moles value. Again, we're going to use the equation moles equals mass divided by relative molecular mass, and we now need to rearrange it to find what the mass is. So we're going to use the equation mass equals moles times relative molecular mass. So we'll do the moles as 1.04 times the relative molecular mass of ethanol, 2 carbons, 6 hydrogens, 1 oxygen, giving us a final answer of 47.8. In this question, we need to calculate the mass of aluminium needed to react with 50 grams of chlorine gas to produce aluminium chloride. So the first thing we'll do is rewrite the equation so we can see it a little bit more clearly. And we're given the mass of chlorine in the question, so we can use that to work out the moles of chlorine. We know that moles equals mass divided by relative molecular mass. So we're going to use the 50 grams of chlorine we're given in the question, divided by its molecular mass, which will be 2 times 35.5, giving us a moles value of 0.704. Now remember, this moles value we've calculated represents the 3 equivalents of chlorine. So we need to find out what 1 lot equals. So what does 1 mole equal in this equation? In order to do that, we'll need to divide the amount of chlorine, the 0.704 moles of chlorine, by 3. So this shows us that 1 mole in this equation is equal to 0.235, because the moles of chlorine, 0.704, divided by 3 equals 0.235. We have 2 moles of aluminium in this equation, which means the number of moles of aluminium is going to be 2 times our 0.235. Meaning that in total we're going to have 0.47 moles of aluminium, because we know 1 lot equals 0.235, so 2 lots, the amount of aluminium, must equal 0.47. Now we've got the moles of aluminium, we need to work out what the mass is. And again, we'll use moles equals mass divided by relative molecular mass, rearranged to give mass equals moles times relative molecular mass, which for aluminium will be its moles, 0.47, times its atomic mass of 27, giving a final answer of 12.69 grams. When we talk about concentration, we're referring to the measure of the amount of a substance in a given volume. So for example, if you imagine you had a beaker with 2 litres of water in, and you dissolved 5 grams of a solid in that solution, you could say that the concentration is 5 grams in 2 litres, or 2.5 grams per litre. Just like with moles though, we can go into a little bit more detail with this. So there's an equation linking the concentration, the moles and the volume. And that equation is moles equals the concentration of a solution times its volume. As before, you need to be able to rearrange that equation to find both the concentration and the volume. So concentration equals moles divided by volume, and volume equals moles divided by concentration. We use the units of decimeters cubed for the volume. And 1 decimeter cubed equals 1,000 centimeters cubed. Remember, a centimeter cubed is the same as a milliliter. Therefore, to convert from centimeters cubed to decimeters cubed, you'll need to divide by 1,000, and you need to remember this for the exam. So the units of concentration are moles per decimeter cubed, and the units of volume are decimeter cubed. So to put this together in a worked example, we need to calculate the concentration of a solution with 2 moles of a salt in 500 centimeters cubed of water. The first thing we need to do is to convert the units from centimeters cubed to decimeters cubed. So we'll divide the 500 centimeters cubed by 1,000, giving us 0.5 decimeters cubed. We know that moles equals concentration times volume. This question is asking for concentration. So we would rearrange the equation to give us the concentration, which means we'd need to do moles divided by volume. Both of these values are given in the question. We're told that we've got 2 moles in a volume of 500 centimeters cubed, which we've converted into decimeters cubed. So the calculation we would do is 2 divided by 0.5. Giving us a final answer of 4 moles per decimeter cubed. And you can see the units of moles per decimeter cubed either written as moles slash dm cubed or moles dm to the power of minus 3. They both mean the same thing. This final example is going to put together using the moles and the mass calculations and the moles and the concentration and volume calculations. So we need to calculate the concentration of a solution containing 3.7 grams of calcium hydroxide in 0.25 decimeters cubed. We've been asked to calculate the concentration, so we must be using the moles equals concentration times volume equation, but we'll need to rearrange it to find the concentration. So to get our final answer, we'll need to use concentration equals moles divided by volume. In the question, we're given the volume as 0.25 decimeters cubed, but we're given a mass rather than a moles. So we need to convert this mass of calcium hydroxide into a moles before we can use this equation. So just like earlier in the video, we're going to use moles equals mass divided by relative molecular mass. So the moles of calcium hydroxide will equal the mass of 3.7 divided by the relative molecular mass of 74, and you could calculate that by adding up the relative masses of each of the components of calcium hydroxide, giving us a moles value of 0.05. So then using our concentration equals moles divided by volume equation, we can say that the concentration of calcium hydroxide will equal the moles, 0.05, divided by the volume we were given in the question, 0.25, giving us a final answer of 0.2 moles per decimeter cubed.